Beyond the hype, understanding serverless computing. Beyond the hype, understanding serverless computing. Serverless computing has been a buzzword in the IT industry for a few years now. But what does it really mean, and how does it differ from traditional computing models? In this article, we'll explore what serverless computing is, how it works, and its benefits and limitations. What is serverless computing? To understand serverless computing, let's first talk about traditional computing models. In the past, you would need to spin up virtual machines or containers to run your applications. This required you to manage infrastructure, including operating systems, software dependencies, and scaling. Serverless computing eliminates the need for managing infrastructure by allowing developers to run code without having to worry about the underlying machines or containers. In this model, the Cloud provider manages everything from server allocation to patching and upgrades. How does it work? Serverless computing works on a pay-as-you-go pricing model, where you only pay for the exact amount of compute power used. The cloud provider then dynamically allocates resources based on demand. ND scales up or down as needed. In serverless computing, applications are broken down into smaller, discrete functions that can be executed independently. These functions are triggered by an event, such as a website visitor clicking a button, and run only for the duration of the event. Once the task is complete, the resources are released, and the function shuts down. Benefits of serverless computing. One of the significant benefits of serverless computing is cost savings. By only paying for the exact amount of compute power used, you avoid paying for idle resources. This can result in cost saving of up to 90% compared to traditional computing models. Serverless computing is also highly scalable. With traditional computing models, scaling up or down requires either spinning up new virtual machines or containers or manually adjusting resource allocation. With serverless computing, the cloud provider dynamically allocates resources based on demand. This means your application can automatically scale up or down to meet the needs of your users without worrying about resource management. Another benefit of serverless computing is improved developer productivity. Since developers don't have to manage infrastructure, they can focus more on writing code and building applications. This and result in faster development cycles and quicker time to market for new applications. Limitations of serverless computing. While serverless computing has many benefits, it's essential to understand its limitations. One of the biggest challenges is vendor lock-in. Serverless computing requires significant cloud provider involvement, and each cloud provider has a unique implementation. This makes it difficult to migrate applications between providers, which can be problematic for companies that want to avoid vendor lock-in. Another limitation of serverless computing is that it's not suitable for all workloads. Since serverless computing is event-driven, it's best suited for applications with sporadic, short-lived workloads. Applications with long-running processes or consistent workloads may not be cost-effective in a serverless environment. Finally, There are performance limitations to serverless computing. Since functions must be executed in response to some event, there may be a latency delay for the first request. Additionally, there are constraints on the amount of memory and execution time allocated to each function. Use cases for serverless computing. Despite its limitations, serverless computing is an excellent choice for certain types of applications. Here are some use cases for serverless computing. 1. Event-driven applications, applications that handle events, such as IoT sensors or